Houston, we have a podcast. Welcome to the official podcast of the NASA Johnson Space Center, Episode 7, Total Eclipse Over America. I'm Gary Jordan, and I'll be your host today. So this is the podcast where we bring in the experts, NASA scientists, engineers, astronauts, all to tell you the coolest stuff about NASA. So today we're talking about eclipses with Mark Matney. He's a space debris scientist here at the NASA Johnson Space Center in Houston, Texas, and he also has degrees in astronomy and space physics and is an avid eclipse aficionado. We had a great discussion about what an eclipse is, some of the history of eclipses, and some of the science that we've learned and continue to learn from them. It was an exciting conversation, especially because on August 21st, 2017, a total solar eclipse will sweep across America. Mark and I talked about where the eclipse will pass through and how you'll be able to see it. They don't happen very often. The last time a total solar eclipse happened over the States was back in 1991, and we won't see another until 2024. Anyway, we'll get into all that good stuff during this episode. So, with no further delay, let's go light speed and jump right ahead to our talk with Dr. Mark Matney. Enjoy.
T-minus 5 seconds and counting. Mark. Launch commit lights are correct.
Here she goes. Houston, we have a podcast.
All right, well, Mark, thank you for coming on the podcast today. Perfect timing because very soon we're going to have a total solar eclipse that's going to pass over the United States. And so I think this is a good chance for us to sit down and talk about eclipses. And you went above and beyond for this one, Mark, because you have a lot of different things. I mean, we're talking a lot of science. We're talking a long and detailed history of eclipses. You know, this is not just, oh, look at that pretty eclipse. No, NASA's going all out for this. Is that fair to say?
Well, I think this is, eclipses have been part of human history as far back as we can record. People have been fascinated, scared, terrified by eclipses.
Oh, sure.
And a lot of important scientific discoveries have been driven by eclipses. I think today, we're doing some science today, but much of the important science is done in the past. But this sort of links us in some kind of way to those earlier scientists who were trying to puzzle out the mysteries of the universe by using this amazing sight in the sky. So we have some science that's going on. We have some citizen science that's going on. And there's going to be a whole lot of people traveling to see this eclipse. In fact, I was reading that this eclipse is the first cross-continent eclipse across the United States since the interstate system was built. And so we might see one of the largest migrations of Americans in a short period of time that we've ever seen. So because there's going to be a lot of people, perhaps tens of millions of people traveling to see this eclipse.
That's very true. And they're all going to be, closer to that nice thin line where we're talking about that path of totality. And we'll get into that really shortly. But, let's start at the very beginning, right? So we're talking about a total solar eclipse. This is great, passing over the United States. But what is that? What is a total solar eclipse?
So a total eclipse is when the disk of the sun is completely covered by the moon. So the moon size is maybe slightly larger than the sun, so you can get a complete coverage. Mm-hmm. This particular eclipse is going to be about 2.5 minutes of totality. Some eclipses are as high as 7 minutes. Some of them are just a few seconds.
And it's just the way things are aligning?
Well, it turns out that the moon is actually not on a perfectly circular orbit. It's in a slightly elliptical orbit. So sometimes it's a little closer and sometimes a little farther.
Oh, I see.
And so as a result, it's a little farther. It doesn't quite cover the surface of the sun. And what you end up with is a narrow ring all around. That's called an annular eclipse. Uh-huh. And if the moon's a little larger, in other words, a little closer, it appears a little larger in the sky, you get a total eclipse. And sometimes we actually have what's called a hybrid eclipse, where you get an annular eclipse, but the mountains on the moon make it so it's actually a broken ring in the sky. It's so close because actually the mountains peeking up cover part of that sun ring.
So can you see some of the sun peeking through those valleys, I guess?
Yes.
Oh, interesting.
And then at that one, it turns out if you could get higher in the altitude in a balloon or a plane, you might see a total eclipse in those guys. But that's a special kind of eclipse. It's actually quite rare.
Wow.
And then we also have a partial eclipse, and that's what it turns out this eclipse is interesting. As far as I can tell, anyone in any of the 50 United States, weather permitting, should be able to see a partial eclipse, including Alaska and Hawaii. The partial eclipse is where the disk of the moon covers part of the sun but doesn't actually get to it. It's off to one side.
Okay.
And so and we're going to get a pretty good partial eclipse here from Houston. But I think everybody, like I said, somewhere in the United States, one of the 50 states, should be able to see a partial eclipse.
That'll be cool.
By the way, it's August 21st. We didn't say the date.
Yes, August 21st, and this will come out August 18th. So this will be will be right next to
Perfect.
it. Yeah,
Okay.
absolutely. So partial eclipse. Is there a way that is very apparent to observe that? Like, will the sky get a little bit darker? Or
It depends on the percentage. When it's like about 50%, it's hard to notice. But once you get on to 60, 70, 80, 90%, the sky takes on an unusual color. And in fact, that's one of the things I'm going to recommend eclipse observers. Just kind of note how the sky changes color, because it's an interesting phenomenon.
Yeah.
But unless it's in ancient times, people did not even notice a partial eclipse unless it was like 80, 90%, because they started to see the sun dim, and they would look up at the sun and see that it was no longer a disk in the sky.
Wow. Okay, so from here in Houston, what are we expecting percentage-wise?
Well, I tried. It's about somewhere around 70%. I don't know the exact area, but there are several tables. Also, that's another thing is where you are, where the maximum eclipse changes on the clock. So there are computer resources where you can look and put in your location or your city and find out when the maximum eclipse is and how much.
Oh, okay.
Okay.
Very cool. That's a lot of good stuff. All right, so that's 70%. We'll be able to see
Something like 70%, yeah.
somewhat noticeable change in the sky then, at least here from Houston. That's really cool. So yeah, you said total versus partial. This is the solar eclipse though, right? This is when the moon is going in between the Earth and the sun.
Right.
Like you said, they're relatively the same size in the sky just based on distance and size.
Right.
And so it, only blocks off this tiny little strip shadow that's going to go across the United States. And it goes, you said, it happens quite often, but just, I guess, at different parts of the world.
Correct.
It just so happens that it's going to line up this time going from coast to
and
coast.
sometimes it's an annular and something. But it turns out we get from 3 to 5 solar eclipses every year.
Oh, okay.
Which is actually kind of surprising.
We meaning the Earth.
Someone on the Earth can see an eclipse. We actually have fewer. There's another kind of eclipse called a lunar eclipse. And the lunar eclipse is when the Earth gets between the moon and the sun.
Right.
And so as the moon moves into the shadow, it starts to turn dark and sometimes has an interesting red color.
Yeah.
It turns out there are fewer of those than solar eclipses. But
Really?
because a whole hemisphere can see it, you can see them much more often than solar eclipses.
Oh, okay.
Because you're looking up in the sky and seeing the moon eclipse. So anybody on that side of the Earth can see it, weather permitting, of course.
Wow. Why is it that color, though?
Well, that's an interesting phenomenon. As you know, the sky is blue from the scattering of particles in the atmosphere. It scatters the blue light, but the red is transmitted just like we see at a red sunset. Well, the Earth's atmosphere actually refracts the red light. And so if you were standing on the moon during a lunar eclipse, the Earth, of course, would block the sun, but you would see this red ring around the Earth, which is the atmosphere refracting the light of the sun.
So that's the red ring of the Earth refracting off of the surface of the moon?
No. It's the light is coming through the atmosphere and refracting slightly to your position on the moon. So you would see this narrow red glowing ring around the Earth.
Oh, wow.
So but of course, no one's ever seen that.
Yeah.
Maybe someday when we have a base on the moon.
So wait, okay. So this is assuming that, you're assuming that you are an observer.
You're an astronaut
on the moon.
standing on the moon, right?
I see, and there's a red ring.
Yeah.
So what about the lunar eclipse, the perception from the Earth? It doesn't a lunar eclipse the moon looks a little orange?
Yeah, it's orangish sometimes. It actually depends on. It depends on the what's happening in the atmosphere.
Oh, okay.
For instance, I saw an eclipse in 1982. We were expecting the red moon, but in fact the moon looked charcoal gray, and that was right after the El Chichon volcano in Mexico erupted, and so the dust from the volcano had changed the dust in the atmosphere, so we didn't get much red. So it actually, you never know what you're going to see when you see lunar eclipse. But they're often red, and again, that's the red light that is bent by the Earth's atmosphere and shines on the moon.
And it's reflecting. Interesting. So it's all entirely about perception then. It's about so you're a person on the Earth, and this is what you perceive from the perspective of Earth. If you were outside floating, millions of miles away, just observing it from, afar, it would just look like the Earth and the moon. The moon wouldn't look a certain color.
Well, you could see the color because it's lit up with that color. Let's change it around. Let's say you were on the moon looking at the Earth during the solar eclipse, and we have some photographs from the ISS of previous eclipses, and you actually see you can actually see the dark shadow. You can't see the sharp edge of the shadow, but you see this fuzzy black thing on the surface of the Earth, and so you would see, but instead of being the whole Earth swallowed up, you just see this black fuzzy spot moving across the Earth from space.
Interesting.
So hopefully, it depends on where the ISS will be at the time of the eclipse, but hopefully they'll be able to photograph it from. They probably will not be in the eclipse path, but they can look down on the Earth and see the shadow, hopefully, of the eclipse.
Yeah, I think they are predicting that the ISS is going to be somewhere over Canada, but we'll have a nice view of the states whenever it's actually the solar eclipse.
It would be very, very coincidental if we happened to fly through the shadow, because the shadow is very narrow. It's going to happen, but it's just going to be...
The odds are against us.
The odds are against us. So a lunar eclipse happens at the full moon.
Okay.
When of course the sun is on the other side of the Earth and the moon is. If you're standing on the Earth, the sun's behind you because it's nighttime, and you see and a solar eclipse happens at a new moon when the moon is you can't really see it in the sky because you're seeing the dark side of the moon.
So you'll never see a crescent moon in a lunar eclipse. It's just
no. It's definitely a full moon. It's full as it gets. Another thing is lunar and solar eclipses are often paired because that tilt of the moon's orbit when the point where it crosses the Earth-Sun orbit plane is on both sides. And so usually we get an accompanying lunar eclipse with a solar eclipse. And in fact, the accompanying lunar eclipse for this eclipse is on August 7th, and it'll be visible from Europe, Africa, Asia, and Australia.
Oh, okay. Well, there you go.
Was visible, I guess.
August 7th. Yeah, I guess. Oh, man.
You want me to say that again?
If we can go back in time.
Yeah, that's right.
Okay, so so that's kind of from the perspective of Earth, right? We got solar eclipses, and when the moon is in between us here on Earth and the sun, and then the opposite for the lunar eclipse. Right. What, in general, if you had to give like a general overview, where else in the universe do eclipses happen?
Everywhere.
How about that?
Anywhere where you have bodies moving around, one will often eclipse the view of another, but usually you won't get to see the amazing sight on Earth because it's very rare that the object eclipsing looks in the sky the same size as the sun. So we know, for instance, there are eclipses caused by Jupiter's moons as it orbits Jupiter, and we can see this. You can see the shadow on the surface of Jupiter, or the clouds actually of Jupiter.
Right.
And in fact, there was a fellow named Ole Romer, if I pronounce him correctly, back in the 1600s that first detected the finite speed of light by looking at the timing of those eclipses on Jupiter. So that's one of those science things that eclipses have allowed us to do.
That's amazing. Just by looking at shadows across the universe, you can get all this crazy science.
And sometimes I know we've done occultations of stars where a planet moves between us and a starlight and a star, and by measuring that star, we've seen we've found the rings of Uranus as the star would twinkle would blink out just before Uranus crossed the star. So you can actually do things like look for difficult to see rings, or also as the light comes through atmosphere, sometimes you can see the absorption of different chemicals in the atmosphere of the planet.
And then understand the composition of the planet itself. Exactly. That's amazing.
Let me add one thing we hadn't talked about.
Yeah, sure.
I found an interesting statistic, and it said that if you picked a random spot on the Earth and you just stayed right there, you would see a solar eclipse about once every 375 years, on average.
Okay, so you should move a little bit.
Yeah, well, you're not following. So during a normal person's, say a normal long lifetime, say 70 years, we're looking at a 20 to 25% chance that you would sometime in your lifetime see an eclipse, a total eclipse of the sun. So yes, it's rare, but not totally unknown. But so I just know that one never comes by my house, so I have to go chase it down.
Well, that's the great thing is we have NASA, folks at NASA actually looking at this stuff and making predictions. We know exactly where it's going to be on August 21st.
That's correct. That's
correct. So that kind of will help you see it a little bit too. I think one of my favorites, though, when it comes to eclipses across the universe is Kepler, right? So if you think about, you said occultations is one of them. That's when something passes in front of a star and changes the light that we're receiving.
Right.
That's how we are detecting planets outside of our solar system, correct?
That's correct. The Kepler mission is looking at a large group of stars, and monitoring them constantly, and it has very, very sensitive instruments. And so they can look at very small dips in the light as a planet, a previously unknown planet, transits the face of that star. And we've been able, and when they see them repeating, they can work out the relative sizes of the planets and their period, and work out where they are in orbit around that star. And we've seen, I don't know what the count is, 1,000?
Yeah. We keep finding more and more.
There's a bunch of them. So this is actually one of the most interesting discoveries I think astronomers have made in the last several years, is that our galaxy is full of stars with planets.
That's
and it's pretty exciting. It's kind of Star Trek stuff.
It is, especially just recently the discovery of the TRAPPIST-1 system.
Yes, indeed.
Those we're talking about Earth-like planets, and some of which are in what we like to call the Goldilocks zone, right?
That's right.
And that's water doesn't freeze. It doesn't.
It's not too hot. It's not too
not
cold.
Not too cold, right? And liquid water can exist, and that's conditions for life, and it's very exciting.
Yes, it is.
That's what we're looking for, right? Life outside the universe. And
I'll also mention we also have transits here, just like what we see with Kepler, of the planets Mercury and Venus, which are inside the orbit of Earth. And we recently had a Venus transit visible from the U.S.
2012, right?
That's right. I think it was 2012. And I've also seen Mercury transits as well. Those have an interesting history because scientists in the 18th century were they could figured out the relative distance to the different planets, but they didn't know an absolute distance. And they were actually going to use different observers on the Earth to measure the transit of Venus to try and get an absolute scale. And so that was the cutting edge science in the 18th century.
Wow.
But that's another point where transits and eclipses have been an important part of the history of science.
Amazing. I mean, that's a kind of a big theme here, right? Especially for eclipses is the science that we can get from observing these phenomena.
Right.
So, I mean, from here on the ground, what are some of the things that we can learn? And I guess in the instance of a solar eclipse, but eclipses in general, what are some of the things that we can learn from studying these? Well,
let's kind of go through some of the discoveries that were made with eclipses. So from we all look up at the sun and see a bright disk. That's called the photosphere. It's very, very bright, and we'll talk about that in a little bit. That's the part we're familiar with. It's about 10,000 degrees Fahrenheit. It's nice and hot. But during eclipses, astronomers notice some red layer, a thin red layer around the sun, and that's known as the chromosphere. And that was discovered by eclipses. And it turns out the chromosphere is due to emissions from atomic hydrogen in the sun's atmosphere.
Okay.
And so the SOHO spacecraft sometimes show. The SOHO spacecraft is constantly monitoring the sun, and one of its instruments is a hydrogen alpha filter, and you can see what that chromosphere looks like. It's a very thin layer of the sun. Again, we discovered by looking at eclipses. The next section. Oh, by the way, some scientists in 1868 there was a new instrument that was developed called the spectroscope, and the spectroscope splits light into its component colors, and they had discovered that there were specific lines. Almost like a fingerprint that defined that were unique to each chemical element. Okay. And so some scientists were very excited to use the spectroscope to look at the eclipse. And in the chromosphere, they saw some lines from an element they had never seen before, and they couldn't figure out what it was. So one of the scientists named it after the Greek word for the sun, Helios. They named it helium. And it was several decades before helium was finally isolated and studied on the Earth, but it was first discovered in the sun's atmosphere.
How about that? That's is it called spectroscopy?
Spectroscopy, yeah. And use a spectroscope for the spectroscopy.
Yeah, and studying I guess there's little gaps in the light, they look like gaps.
Sometimes there's bright lines, sometimes there's dark lines, and it depends on the situation. But the point is, these lines are like a fingerprint, and that's how we understand the components of stars millions of light years away. We can.
So you said photosphere, and then you discovered the chromosphere.
Chromosphere.
Right? So what's the difference between those?
Well, the chromosphere is actually a very thin layer. Like it's actually starts as cooler than the photosphere, and then it heats up again. And there's solar astronomers are always trying to figure out the exact details. But what gets interesting is when you look up at the eclipse, when it's totally eclipsed, there's what looks like a halo or a garland or a crown around, and that's called the corona. So the chromosphere is a transition between the hot photosphere and the much hotter corona. And the corona's it's more than 100 times hotter than the photosphere. It's very, very hot.
Wow.
And that's, like I said, this halo you see around the sun. That is actually very important to monitor that part of the sun in predicting solar storms. And solar storms affect things like satellites and our communication and our power systems. And so there are solar astronomers who are constantly monitoring the sun, looking for these types of solar storms. But the corona was discovered by looking at eclipses.
Wow.
And in fact, it's so important that we have launched satellites that create artificial eclipses. They put a little obstacle in the way so we can monitor the chromosphere. The corona at all times.
So, I guess, are they hard to predict, solar storms? And
they're getting better at it. The big thing is they need to be able to see on the far side of the sun. So we've actually launched a couple of spacecraft called Stereo, and they're now on the far side of the sun. Not totally. They're part way around the Earth's orbit, but they can see the other parts of the sun, and we can see storms developing as the sun rotates around. The sun actually rotates also.
Wow. So what happens if, say, there's an instance if there's a solar storm and it does disrupt satellite communications, coverage, whatever it is? What can we expect if that were to happen? Are you talking about cell phones? Are you talking about what would happen here on Earth?
Well, one of the worst things they're worried about is a really, really big storm, solar storm, which could knock out power grids at certain areas, and so you can actually have power outages. But usually satellites, they put them in safe mode, but it can damage satellites, and as you know, telecommunication is a multi-million-dollar business.
Right.
So there's a lot of interest in solar storms.
But they have a safe mode to
that's right.
Yeah, that's amazing. Okay, so they just put it in there if they see something bad.
It's still dangerous, but they can put it in a safer mode. Let's call it a safer mode. One other thing,
just a little bit though.
One other thing that was observed during eclipses is there's sometimes these little arcs. They're not little; they're bigger than the Earth. But these little arcs of plasma jutting off the sun, and you've probably seen pictures of them. They look like arches or flames coming off the sun. They're called prominences, and they're plasma in the strong magnetic field of the sun moving through the atmosphere, and they're really quite spectacular.
Yeah, I've seen some images and videos of them. They really are. It's amazing.
Again, those were discovered by eclipses. And I'll tell you another set of experiments. It turned out that by the mid-1800s, scientists had started working out the mathematics of planets, and had noticed when a planet gets perturbed in its orbit, gets nudged a little bit, they said, well, that must mean another planet that's tugging on it with its gravity. And that's how Neptune was discovered. They saw the perturbation in the motion of Uranus. And they noticed that there was a slight perturbation in the orbit of Mercury. So scientists began speculating that was due to another planet even closer into the sun, which they nicknamed Vulcan. So what happened was they then sent, in the 1860s and 1870s, scientists deployed around the world for some eclipses to try and look for Vulcan. And they didn't find anything, which puzzled them. They looked at multiple eclipses multiple times, no Vulcan. But in 1915, Albert Einstein began communicating his work on the general theory of relativity. And Einstein had postulated that gravity is caused by the bending of space-time. And one of the predictions of his theory was that you would see this perturbation of the orbit of Mercury. So he explained that with his general theory of relativity. But another prediction was that this bending of space-time would actually bend light. So he showed why there wasn't a Vulcan, but then he said if you look at an eclipse of the sun and look at the light of stars very, very close to the disk of the sun, you should be able to see the light bent in a way that it displaces the apparent position of the star. In 1919, Arthur Eddington, the British astronomer, deployed for an eclipse out in an island in the Atlantic Ocean, and they actually measured this slight change in the apparent position of stars. And it was a huge event because when Einstein postulated his theory of general relativity, it was crazy. It was overturning Newton. And here his prediction turned true,
right.
and that's sort of what propelled Einstein into his fame was that discovery. So that was perhaps the most important scientific discovery ever during an eclipse was showing how the light of stars is bent by the presence of the mass of the sun.
So it was just the mass of the sun.
That's
and
right.
It was no Vulcan.
No Vulcan.
Yeah.
Although there's two eclipse stories related, sort of quasi-related to the same thing there.
But everything comes together, right? That's why there's like going back to the general theme here. A lot of science to learn from these eclipses.
Let me talk about a couple of things that are going on with the science this time around.
Okay.
We have one group that's going to have a series of of telescopic cameras set up along the eclipse path. And they're going to try and take video of the inner corona, which is very difficult to see except during the eclipse. And the idea is one camera will record a little segment of the inner corona, and the next camera will record the next segment, and they can stitch them together and have a rather extended video of the corona. So for scientists who study the interaction of the corona. Another one is some other scientists are going to be studying the polarization, which some light is polarized in different directions. That tells us information about the magnetic fields and other things. But they're going to be looking at the spectrum and the polarization of the inner corona, which is difficult to measure with other ways because it's difficult to get so close to measure such dim phenomena so close to the disk of the sun.
And this is going back. I'm sorry, you might have already addressed this, but these are NASA telescopes, or these are others?
It's a variety of NASA's cooperating on some of these, and some of them are universities, and some of them are amateurs. So it's actually a whole team of different kinds of people
Wow,
that NASA's
okay.
helping to coordinate some of these.
Yeah, all working together. Okay, cool.
We've got another group that are actually going to repeat the general theory of relativity experiment with some more modern digital equipment with more sensitive cameras to look for some very dim stars, again, to try and fine-tune those measurements to see how close Einstein got to the prediction.
Wow.
And then we also have some radio enthusiasts who are, during the daylight, the sun ionizes gas in the upper atmosphere, and we have an ionosphere, and it both enhances and sometimes interferes with radio communication. So these scientists are going to look at how the ionosphere changes as the sun gets eclipsed and the sunlight starts to drop off and then go back up again. So they're going to observe how the ionosphere changes.
Interesting.
So lots of interesting experiments, and of course, and many of these are by these amateur citizen scientists, which is kind of a fun thing too.
Yeah, absolutely. So we're measuring the Earth's atmosphere. We're measuring a lot about the sun.
Mm-hmm.
I know out of here, the WB-57, those high-altitude planes, they're going to be flying above most of the atmosphere, about 90% of it, and they're going to take a look at the sun and study the sun's corona
Yeah, good.
and measure how energy goes through the sun's atmosphere, but then also take a look at Mercury.
That's right. I wanted to tell you, when you see the eclipse, you will see a number of planets visible in the sky. So if you get a chance, you'll see stars. Venus is off to the west. Mars is even closer. Venus is about 35 degrees to the west. Mars is about 10 degrees to the west. Mercury is about 10 degrees to the east. And Jupiter is way over on the other side of the sky at 60 degrees to the east. And the star Regulus, which is a bright star, will be about 5 degrees to the east of the sun. So you can see if you can see that.
And this will happen during totality.
During
right?
totality, because the stars will come out.
Wow, amazing. So you'll be able to see all these, and you're talking about from the perspective if you're looking up and,
Right.
the sun, once it goes to totality, and we can get to safety in a minute, but I do know once it gets to totality, you can take off your glasses
That's right.
for about that 2 minutes, right?
Yeah.
And then that's when you'll be able to
Yes.
see all those different parts. That's really cool.
Yeah, that's it. Let's talk a little about the history, because there's some interesting history of eclipses.
Sure, yeah.
The most famous story, which is probably legendary, but the story about a Chinese astronomer, or possibly two Chinese astronomers, named Shi Hu, who was hired by the king. He was the high astronomer, the head astronomer, to make predictions about, primarily with astrology, to make sure that nothing bad was going to happen to the king. Well, apparently there was a solar eclipse he did not predict.
Oh.
And apparently he had a little too much to drink, and he wasn't on the job when the time came. And the Chinese actually thought, and a lot of ancient cultures thought, that something bad was happening. The Chinese thought a dragon was swallowing the sun, and they would bang on pots and pans to scare the dragon away. And that's actually still practiced in many parts of the world, that bang on pots and pans.
Yeah, they don't know the science behind this total solar eclipse.
That's right.
Right.
And I think part of it is tradition that's passed on.
Yeah, tradition, yeah.
Well, unfortunately, this poor Chinese astronomer that didn't do his job, he got executed. So fortunately, we don't hold our scientists to the same level there.
Very thankful of that.
Yes.
I'm sure we are, yeah.
But lots of ancient people were scared of eclipses because they thought it's a very amazing thing to happen in the sky, and they were worried about it. It's a warning of some tragedy. Mm-hmm. So early scientists in multiple cultures, the Mayans, the Babylonians, the Chinese, studied eclipses and tried to understand and predict when they would occur. It turned out there was a Greek by the name of Thales who predicted an eclipse in 585 BC. and this is recorded in the Greek historian Herodotus. There was a big battle going on between two countries. They were the Medes and the Lydians in what's now Turkey. And there was a war going on, and they had lined up for battle, and they were about to do battle, and suddenly there was a solar eclipse.
Oh.
So needless to say, the two generals met in the middle of the field and said, maybe we ought not to fight today. And so they drew up a peace treaty, and those two countries never fought again.
All right.
So
an example of solar eclipse saving lives.
That's right, indeed. And so, but what happened was a lot of these, as people began to learn to write things down, the Babylonians on clay tablets and the Chinese court records and the Greek historians, people began to pull together this information to understand how to predict eclipses and understand how the cycles occur, and that helped. That sort of spawned the whole science of astronomy. Is how the mathematics occur on these objects, and one of the things they discovered was called the Saros cycle, and this actually Edmund Halley named it the Saros cycle. They had different names in ancient times, but what they discovered was that an eclipse will recur approximately every 6,585.3 days, which is 18 years, 11 days, and 8 hours. So it turns out that the eclipse we're about to have is part of a Saros cycle that occurred. The last one was in Europe on August 11, 1999. And the next one will be in Asia and the Pacific on September 2nd, 2035. And it looks almost exactly the same, except shifted by 8 hours around the Earth, or 120 degrees in longitude.
Oh.
So these repeating cycles were how the ancients were able to predict eclipses.
How about that? Wow.
And it's just all the different cycles of the sun and the moon add up to this repeating cycle of eclipses.
Interesting.
Another thing that science that was done in ancient times was the Greeks looked up at a lunar eclipse when we were talking about how the moon moves into the shadow of the Earth. And what they discovered is when the moon is near the horizon and eclipsed, the shadow of the Earth is not a line if the Earth were flat. It's still round. So the Greeks just realized that the Earth must be a sphere based on the shadow of the Earth on the sun, on the moon during an eclipse.
Oh, wow.
So that was the first scientific discovery that the Earth was indeed a sphere.
Back in the Mayan. Wow.
Sorry,
okay.
back in the Greek times. That was
that was Greek times.
Yeah, that was the
okay.
Greeks.
Okay. Interesting. Wow.
So there's a lot of interesting history associated with eclipses.
Absolutely. We learned a lot through history. I mean, we're talking about the shape of the Earth. We're talking about
nature of the sun.
battles, the nature of the sun.
Yep. The earliest eclipse that as far as we know is recorded, that Chinese eclipse was probably about 2000 BC. Although there's maybe the one in 2137 BC. But the one we're sure about was there was an eclipse recorded in the town of Ugarit in what is now, I believe, Syria. Was May 3rd, 1375 BC. It was recorded that the sun grew dark. So there's a number of those recorded in ancient texts on tablets.
Okay, so the Chinese one was not recorded?
Well, we just know that it's actually probably semi-legendary. We're not sure.
Okay.
But this is the one we know for sure. We can date the eclipse.
Yeah.
And actually, that was what I was going to tell you, is we have a number of these dated eclipses. Eclipse of Thales we talked about, eclipse in Ugarit. And what happens if you just take your computer models and put in gravity and everything and just run the sun and moon backwards in time, it turns out the eclipse is in the wrong place. So from that, what we've learned is that the Earth's rotation very, very gradually is starting to slow down. It's been in a long time. It's mainly due to the tidal effects of the moon. It's actually dragging the Earth slightly down. So it's actually in those several thousand years, the Earth has slowed down a little bit, a fraction of a rotation. Oh. But keep in mind, we're talking about 800,000 rotations or something like that since those times. And so the Earth's rotation has changed just a little bit in those times. But that's another discovery we've made, that you need that long time scale to see this very gradual slowing down of the Earth's rotation.
So over that long period of time, you said a fraction of a day, is it like an hour? A couple of hours?
It's a couple of hours, I
wow.
think. Yeah. And recently some scientists have gone back and looked at Chinese records and again been able to fine-tune that. So that's using ancient records to fine-tune some modern science. So.
All right, cool. Okay, so let's go to this eclipse coming up on the 21st.
All right, you want to talk about safety or what to expect?
All of it. Let's do it.
All right, let's talk
However
about.
you want to start.
Let's talk about safety a little bit.
Okay, safety.
Okay, everybody has heard, don't look at an eclipse, you'll go blind, right? We've all heard that.
Yeah.
And I remember as a boy puzzling over that. What is it about an eclipse that makes it so dangerous? Mm-hmm. Well, it turns out you don't want to stare at the sun ever. It's bad for your eyes. Your eyes are not designed to handle direct sunlight for any length of time.
I feel like it's a good general rule.
It's a good general rule. And when our kids go outside, we say, now kids, don't look at the sun, you'll go blind. It's true, you don't want to look at the sun.
Yeah.
The reason why the eclipse is not any different, it's just you're more likely to stare at the sun during the eclipse because you want to see what's happening. So there's people that think there's some sort of mysterious rays coming off the sun. The only thing is it's just the sun like we're normally familiar with. You just don't want to stare at it. Okay.
Okay.
All right, so that's the first thing. So anytime the bright disk, that photosphere of the sun, anytime the bright disk is visible, even just a little sliver, you really don't want to look at the sun with your unaided eye. It's dangerous. You want to keep your eyes for a long time, right?
Yeah, I would hope so.
But now nowadays we have special eclipse glasses that you can get in museums and different places it's perfectly safe to put those on and look. By the way, don't do what I did. I was checking my eclipse glasses the other day. I looked up at the sun. I said, yeah, and I pulled the eclipse glasses off before I stopped looking at the sun. So then I had a bright blob, just for a second, I had a bright blob in my eyes for a little while. So be careful with them. They're often made of aluminized mylar, and they're kind of silvery. And also, don't put any pinholes or anything in them. You want to keep them like they are.
Keep them. So what are the special eclipse glasses they have? They're just like really intense sunglasses. Is that
kind of what it's super sunglasses, which raises the thing. You want to avoid any homemade glasses. Don't put on multiple sunglasses or something. Don't use smoked glass or photographic film or neutral density filters or anything like that. You're not sure there's enough there to block the light to make it safe. So stick with the kinds that you can get. They're not very expensive, and you can get them online and other places.
Okay.
One exception is number 14 welder's glass is safe because that's designed also for very bright, like the welders use.
Oh, okay.
All right, so that's okay. And an even more important part is don't look at the sun, especially don't look at the bright disk of the sun with any instruments, with telescopes or binoculars, without proper filters on them, because those things actually magnify the strength of the sun. Ooh. And just like when I was a boy, I used to use the magnifying glass on the ants, that could do that to your eyes. So you need to be very, very careful. So I would avoid those unless you have properly designed equipment. Now, don't take your binoculars and put your sunglasses at the eyepiece, because it's so intense it could burn right through your special glasses. So be very, very careful unless you know what you're doing with binoculars and telescopes. Don't even use those.
Right, and that's only a 2-minute.
It's only a 2.5 minute at the most.
Yeah.
So that's that little window of time during totality, after the moon has completely covered the disk of the sun. Mm-hmm. That is the only time you can look safely without glasses.
Okay.
And the brightness of the eclipsed sun and the corona is like the brightness of a full moon. So there's no dangerous rays. You just don't want to be staring at the sun when the sun reemerges. Yeah. So just good rules of thumb.
So when you're looking at it, say you have the glasses on, mm-hmm. Is there a specific amount of time that we can say is safe to have the glasses on and be looking at the moon about to cover the sun? You don't want to stare at it for hours.
No. What you're probably looking for is as the very last piece of the sun starts to disappear, you'll see actually little dots that form, and those are called Bailey's beads. And it's an interesting phenomena. What it has to do with the different brightnesses on the edge of the sun, and also the mountains on the moon. Mm-hmm. When those disappear, that's the time you can take your glasses off, and so you don't want to be because that's actually tiny little pieces of the photosphere of the sun.
Right.
There's the other way. If you don't have the glasses, there's some other ways you can look at. And this, by the way, if you're seeing a partial eclipse, you just want to use the glasses. You don't want to look at the sun directly.
Will you be able to see the moon partially covering the sun with the glasses?
Yes, it'll look like a cookie with a bite taken out of it.
How about that?
Pretty
That's cool.
One method you've probably heard of is a pinhole projector, and it's very easy to make. You need some opaque material like cardboard, and you make a pinhole, and then you project onto like a white sheet of paper an image of the sun. The pinhole acts like a lens, and I think it's important. Don't actually look through the pinhole with your eye. It's not intended to look at the sun. It's a projector. It's a little projector.
You look at the paper.
You look at the paper, and you'll see a little image of the sun and you can see the progress of the eclipse. Another method I used to do when I was in high school is if you take a very small mirror or a large mirror with a piece of paper with a circular hole cut out, and you can reflect the image of the sun onto a shaded wall. and you can watch the eclipse that way.
Oh.
And I tell the story. I was in history class when there was an eclipse of the sun when I was in high school, and I asked the teacher. I said, "Is it okay if I put this in the window and we can watch the eclipse during class time?" The teacher said, "Okay." So we put it in the window, and it put an image of the sun during the eclipse up on the ceiling. We just went along with class, and you could watch the progress of the eclipse.
All right.
So those are the mirror. There's the projector, or your glasses are the three ways to watch the eclipse. And then the only time again to watch the eclipse unaided is during totality, that little short period of time.
Okay, and totality is by far the most narrow section of the U.S.
That's right.
So you really have to be in that spot. And you can go to the website, eclipse2017.nasa.gov, and find out exactly where that's going to be passing through.
That's right. And it starts, I think I started this, but it comes on the West Coast.
Oh, right.
It arrives in Oregon. It goes across Oregon, Idaho, Wyoming, Nebraska, Missouri, Kentucky, Tennessee, South Carolina. It's a nice path that goes right through the middle of the United States.
All right.
And it's a relatively narrow path. And, of course, it's actually moving. It's a round shadow that's moving across the surface of the Earth. And if you're actually anywhere in that band, you will see a total eclipse. The closer you are to the center, the longer it will last, and to a maximum of 2.5 minutes.
All right.
The other thing, though, is the weather.
Oh, yeah.
So it turns out that what eclipse aficionados like to do is they'll look at the historical weather at that point in the U.S. at that time of year. And it turns out some of the areas are more likely to have clouds than others. So it turns out eastern Oregon is a really good place. They tend to have nice, clear weather that time of year.
Okay.
Wyoming, Nebraska, Missouri, all the way to Tennessee tend to be pretty cloud-free that time of year. And then there's another, as it goes over the Appalachians, they tend to be cloudier, and then the little section of South Carolina will also have, hopefully, less clouds than other places. But again, you never know. It's the weather.
Yeah.
All you can do is roll the dice and hope that you're lucky, because if there've been many eclipses that scientists have gone specific trips to see, and it's been interfered. The weather interferes.
Yeah, that's just poor luck. But that's based on
It's
data of
right.
this day over
That's
time
right.
at this place.
How often has it been cloudy on this day at this place?
Yeah,
And
so you're really rolling the dice, but playing the odds. But those based on statistical data
Right.
are better off than others. Very cool. Is there any particular spot during the path of totality that maybe would be better? Like, for example, is it better to go to like a state park and be away from city lights or anything, or is being in the city just as fine?
It's just as fine.
Okay.
It doesn't get totally dark during eclipse. It gets dark, but I don't think that part of it is particularly important.
Okay.
The main thing is actually much more practical. You want to be somewhere where you're close to restrooms. Okay, the eclipse itself lasts 3 hours, and there may be a lot of traffic, so the ability to get around may be limited.
Ooh, yeah.
So just very practical things. Are you close to food? Are you close to supplies and things like that? So let's talk a little bit about what to expect.
Yeah.
As I said, there may be a lot of heavy traffic, so you want to get to where you want to go early.
Okay.
And bring things that you're going to need: your glasses, your eclipse glasses, a camera if you're going to bring a camera, chairs, sunscreen, water, food, toilet paper, anything that you think you might need while you're on the road.
Yeah.
I once had to evacuate here in Houston during Hurricane Rita, and it's maybe a little bit like that. It may be stuck on the road with heavy traffic if you're not careful.
Wow.
So,
Are you talking about people stopping on the highway?
No, I'm just talking about large numbers of people moving to see the eclipse.
To be in the path of
if
totality.
you're traveling. For instance, I'm going to be in the Carolinas, and every eclipse watcher on the Atlantic coast is going to be headed for South Carolina. So the interstates are going to be pretty full. So just
Wow.
allow plenty of time. The total eclipse, the entire eclipse lasts about 3 hours. So it's about an hour and a half up to leading to totality, and an hour and a half until the moon completely uncovers the sun.
Okay.
But again, and one of the things I thought was interesting was the eclipse veterans gave some very sage advice. They said, if this is your first eclipse, don't try to photograph it. Don't try to take telephotos and photo. You'll be so worried about your camera, you'll miss the spectacular nature of the eclipse. So I think that's good advice. And so if you're a veteran eclipse guy and you want to and you want to make photographs of things, that's fine. Let the professionals do it. Just enjoy the experience. I think that's a good idea.
I'm sure there's going to be plenty of imagery coming out from all over the U.S.
I bet there's going to be lots of selfies with people with the moon, the eclipsed sun behind them, but that's fine.
Do you think selfies will come out, at least during totality? Maybe when it's dark enough.
You may need a flash on yourself.
Oh, okay. Flash on yourself. Okay.
Couple of suggestions to do, so a little citizen science you can do. One of them is notice how the sky colors change. They're very unusual colors that you don't normally see, so that's an interesting thing. Also, when there's a tree casting shadows, there are lots of little tiny holes between the leaves that act like pinhole cameras. So sometimes you can see little crescent suns during the partial eclipse on the ground. So you can look for that. It's kind of fun. Take pictures of that.
Oh, that's really cool.
Does the temperature change? Does it feel cooler during the eclipse? Does the wind pick up or calm down during the eclipse? Just so kind of scientific things you can observe.
Are there things that we know of that what atmospheric changes in the Earth?
Well, it does change the heating of the Earth from the sun. Yeah, and you will feel cooler, and people actually have noticed it feels considerably cooler, which will be pleasant probably on August 21st, and especially in South Carolina. So just things to notice. Again, the other thing is, as totality approaches, observers have sometimes noticed what's called shadow bands. And these are alternating light and dark bands that quickly move across the ground, especially where you have light-colored surfaces. And they occur just before totality and after totality. We don't fully understand how they work. They probably have something to do with the atmosphere, the same reason that stars twinkle. But if you can see them, sometimes they're seen and sometimes they're not. It's something to look for. Another thing to observe is right as the totality is beginning, there's just a tiny little sliver of the sun, and it looks very much like a diamond ring in the sky, and it's called the diamond ring effect. And that's definitely when the diamond ring occurs at the end of the eclipse, or the Bailey's beads. That's the time to put your special eclipse glasses back on.
Oh, okay.
But as the eclipse is about to happen, you'll see the diamond ring effect, and then the diamond will go away, the Bailey's beads will go away, and then you'll see the full totality. And again, you can take your eclipse glasses off during totality, but be ready to put them back on.
Yeah.
And another thing you can look around is take a moment while you're enjoying the eclipse. Take a moment to observe people around you. See how people react to it.
Yeah.
Expressions on their face. Another thing is sometimes animals behave strangely during the eclipse. Chickens have been known to roost. Birds behave differently. Even wasps and bees sometimes behave strangely.
Wow.
Cows, dogs, insects, anything you can think of that's close by. Just for fun, observe and see if you notice anything.
It is a strange and rare phenomenon.
It is strange, and they're confused by it.
Yeah.
And by the way, after totality, the whole sequence will reverse itself. So you have all those sequence of things: the partial eclipse, the diamond ring, the Bailey's beads, and that will reverse as the moon uncovers the sun.
Wow, amazing.
So if you miss this eclipse or the weather doesn't cooperate, we have another chance in 7 years from now. In 2024, there will be an eclipse that will move through Texas and up through New England, and it will be another total eclipse of the sun. So we have two in a very short period of time, but it's been a long time since we've had an eclipse. So,
all right. Yeah.
So we're due. We get two. So two chances. And my wife said, well, why don't we just go to the one in 7 years? And I said, well, we don't know what our lives are going to be like in 7 years. So I said, carpe eclipsum, seize the eclipse. So this is your chance.
Fantastic. Yeah. No, I mean, if anything, why not both, right?
Well, why not? We could try both. I may become an eclipse fish junkie, I guess it would be.
Yeah. No, man, it's so cool, and the fact that we're able to predict them, and we can go and we have a bunch of best practices on how you can observe the eclipse the best that you can possibly do it. Yeah. I know. Going back, just one quick thing. Well, you said early. Arrive to your destination early.
Yeah, if you can. Yes.
How early are you? Are you talking about like days or day or hours?
Well, it's difficult to arrive days early now because virtually every hotel is booked along the eclipse path. We're going to be some distance away from the eclipse, so we're going to have to start early. The eclipse is a maximum in South Carolina about 2:30. So I figure if we get off at 8 in the morning, that gives us about 6 hours to get there. And that may or may not be enough time. We'll just have to do the best we can. That was just where I'm staying with relatives. So that's,
okay.
But a lot of people I know have their hotel rooms booked underneath the eclipse, so they can just step outside and watch it. But
Yeah, that's I wish I planned ahead there. That would have been nice. Just get a nice like resort or something and just lay by the pool, watch the eclipse go by. That'd be pretty cool.
Actually, what I had originally planned, I've been planning for this eclipse since I was in graduate school many, many years ago.
Wow.
And I noticed that it would actually go through Grand Teton National Park. And I thought, that's what I'll do. I'll go to the Grand Tetons to see the eclipse. But it turns out the weather's not so, it's a higher probability of clouds there, so I backed away from that. Good luck to those of you that the Tetons, but that would be a beautiful photograph, actually. It's an eclipse over the Grand Teton Mountains.
Absolutely. Let's keep our fingers crossed for that good weather across the board.
Hopefully it'll be clear all across the United States,
Yeah.
and everybody will be able to enjoy the eclipse.
That would be fantastic. Well, I think that's all the time we have, unless you have one more story, but anything?
I have other stories, but there are lots of good stories.
Well,
but,
hey, yeah, actually, we have a website, and if you stay tuned till after the music here, we'll tell you where you can go and check out some more info on the eclipse and learn a little bit more about the history, the science, and all kinds of cool stuff, including the citizen science that Mark was talking about here and how you can, what you can do to observe some phenomena about this eclipse. So stay tuned for after the music there. Mark, thank you so much for coming on the podcast today. I feel like that was, I'm not going to say everything about an eclipse because, like you said, there's definitely more. But I feel like I have a good understanding about eclipses and the science that goes behind it. So, there's a lot about eclipses and a lot that we can learn just from shadows, and it's just amazing that there's so much behind it. So, thanks for coming on the podcast and talking all about it. And everyone, I hope you enjoyed the eclipse on the August 21st. So, thanks again, Mark.
Thank you.
Dock of the space shuttle.
Roger, 0G, and I feel fine.
Shuttle has cleared the
Became
tower.
a theme for all mankind.
Actually, a huge honor to break a record like this.
Not because they are easy, but because they are hard.
Houston, welcome to space.
Hey, thanks for sticking around. So, once again, this Monday, August 21st, a total solar eclipse will sweep across America. If you want to know all the information that we have, if this podcast was not enough for you, go to eclipse2017.nasa.gov. You can find out all the science of eclipses, even more than we talked about with Mark Matney today, where it will be, and then how to safely view it from the ground. Just be sure to make sure that you check the glasses and make sure that they are NASA certified. After talking with Mark Matney after the show, we found out that the shadow itself is going to be 68 miles wide, and then that shadow travels faster than 1,000 miles per hour. So, he went back and he was trying to find the width of that shadow. It's actually a little bit smaller than you would imagine, but how fast it travels, we're talking about some of those planes that are going to be following the shadow and studying it. They're only going to get only a few extra minutes out of it because the shadow's traveling so fast. But if you think about it, it's the moon going around the Earth, so it's probably going to be a little bit faster than you would think. Anyway, you can find out more about the eclipse by following us on social media. Obviously, our NASA accounts will be talking about this, but also here at the NASA Johnson Space Center, you can follow our accounts there. We'll be talking about it. If you follow International Space Station, you can see some of the imagery you'll get from there, 250 miles above the Earth. And then also Ares, Astromaterials Research, you'll find them on multiple accounts, and you can talk. They will be talking mostly about the science of eclipses, and they are also based here in the Johnson Space Center. All of these are on either Facebook, Twitter, and Instagram. If you want to join the conversation and maybe submit some pictures that you are taking from wherever you're going to be observing the eclipse, and then also sort of see what everyone else is doing, the official hashtag for this event is hashtag Eclipse2017. Just use that on your favorite platform and share your experience and maybe ask a couple questions in case all of the information we told you today and anything you can't find on the website, we can still answer even more questions that you have. So this podcast was recorded on July 19th, 2017. Thanks to Alex Perryman, John Stoll, and Tracy Calhoun. And thanks again to Dr. Mark Matney for coming on the show. We'll be back next week.